Hello everyone. This is Lalita Devi, Senior Math Faculty, and I welcome you all once again back to the Sri Chaitanya Academy YouTube live session. So now in our sessions we mostly discuss about the transition course. So where the students moving to the grade 11. So we are going to strengthen our foundation in our subjects. So now we are going to discuss some of the topics that are related to the mathematics. So first most topic that we will discuss is the sets. Okay. So now in our today's session we will discuss about set and what is the representation, various types of representation of set, and then after we will discuss some of the types of the sets. So let's start with the basic definition of the set. So as we know that set is nothing but a well-defined collection of objects. So what is the well-defined collection of objects means? If we take an example, we are having the letters. If we take an example, alphabets. So now once again those alphabets are divided into the consonants and vowels, right? So now we will discuss about, yes, so if we are taking the alphabets, we are having the two types. Those are of your vowels and consonants. So now if we take an example of vowels, those are nothing but A-E-I-O-U, which are nothing but a well-defined objects. It means they are having a common property between them. Those are nothing but our vowels. Okay. So in the same way, if we are having any collection of any well-defined objects, that we are going to call it as the sets. Okay. And whatever the objects we are having in the sets, those are called as the elements. So whatever the objects we are having in the sets, that we are going to call them as the elements. Okay. And the elements in the sets are usually represented by the small letters and the sets are represented by the capital letters. So when can we say that the given situation is a set is nothing but, like, consider a set of natural numbers. As we know that set of natural numbers start with 1, 2 and so on. 1, 2, 3 and so on. And coming to the next, set of prime factors of 135. So how can we find the prime factors of 135? First of all, we will go for the prime factorization. It means if we take 135, if we do the prime factorization, we will get the prime factors as 3, 5 and 1. Okay. So this is one of the prime factorization. So now we will get the prime factors of the 135 as 3, 5, 1, and we are having 15, 27 and so on. So if you take a collection of all these prime factors and if you are placing them as a set, the common property will become, those are all the prime factors of your one number, which is nothing but your 135. Okay. Now what are the situation we can't be considered as a set means? Just consider an example of, we are having the students that are scoring, they are scoring more than 90 marks. Like, we can't predict a student can score the 90 marks, above the 90 marks, right? So we are not sure whether he will be getting or not. So such type of situations will be coming under not a set. Okay. Now let's solve a question on how can we classify the given situation as a set and not a set. Now coming to the first one, which of the following collections are sets? If we take it first one, the collection of honest persons in India. So are we having any particular property or any particular question to mention whether a person is honest or not? It is not possible, right? We are not having a common property which we, with the help of which we can say that the person is a honest or not. So now this will become not a set. Okay. Now moving to the second one, the collection of all prime numbers between 14 and 50. So if you take an example of prime numbers between the 14 and 50, we can start with 17, 19 and next 23 and 31 and 37, 41, 43 and 47. So we are going to stop by 47 only. Why? Because we are going to collect the prime numbers between the 14 and 50. Now moving to the next, the collection of all factors of 24 which are less than 20. So if you take the factors of 24, we can take it as 1 into 24 and next it will become 2 into 12, and next it will be of 3 8s are and 4 6, right? Now the factors will be of your 1, 2, 3, 4, 6, 8, 12 and 24. But now in the question, what is the given condition? We have to take the factors of 24, but those factors should be less than 20. So now the collection, that means the set will become, so I am considering it as set A, which is nothing but 1, 2, 3, 4, 6, 8 and 12. We can't consider 24. Why? Because we need to take less than 20 only. Now moving to the next, the collection of all the rivers in India. So we are having the rivers like Ganga and Yamuna. So we are having a particular set of rivers in India. So if you take the collection of those all rivers, it will form a set. Okay. So now these will be a set. And coming to the next, collection of factors of 24 which are less than 20 is also a set. And coming to the next one, the collection of all prime numbers between 14 to 50 is also a set. Okay. So now whenever we can say, when we can say that the given collection is a set or not means, if we are having a particular property between them, then we can say that the collection is a set. Okay. Now moving to the next, representation of set. So how can we represent the given set means, we are having two methods. First method is we can take the elements that we are having in that set. Otherwise, we can mention what is the common property between all those elements. So depending upon that, we are having the two types of representation. One is the roster or the tabular form, and another one is the set builder form. So let's see what is the roster form. So roster form in the sense, as I told you, that we can take the elements of the set individually. So it means, just if you take an example of factors of 34. So if you take 2 into 17, okay, now I can write it as 2 into 17. It means 2 is a factor and 17 is a factor. So I am writing my factors as individual elements in the set. So these becomes your roster form. So now the set of all natural numbers which divide 42. If you take an example, and if you take the factors of 42, you will get 1 into 42, okay, and 2 into 21, and next 3 into 14, and 6 into 7, okay. So these all are the factors of the 42. Now what we will do is, we will write the terms individually in our set. But coming to the roster form, we are going to write the elements for only one time. We are not going to write the given elements for 2 times, or we are not going to repeat the given terms in our roster form. Now moving to the next is the set builder form. So coming to the another thing we are going to consider in order to represent the set is, we are going to write the common property that we are having between the elements. Now let's see an example. So if x is a natural number and x lies between the 3 and 10. So how can we write the set builder form means, if you take an example of this question, x is a natural number but that x should lie between the 3 and 10. So what are the numbers we are having between 3 and 10? So those are nothing but our 4, 5, 6, 7, 8 and 9. So if I am writing those numbers individually, like 4, 5, 6, 7, 8 and 9. Okay, so here I am writing the elements individually. So it will become your roster form. Okay, and now here if you observe, we are considering an variable. So you can take whether x or y or whatever it was, and this variable is representing the elements of the set. And with that, we are going to write what is the common property we are having between the elements of the set. Okay, now let's solve a problem. Write the solution set of the equation x square plus x minus 2 equals to 0. So first of all, they are asking us to write the solution set. Solution set, how we can write? First of all, we need to find the solutions for the given equation. So let's take it. X square plus x minus 2 equals to 0. Now let's do the factorization in order to get the solutions. So it can be taken as x square plus 2x minus 2 equals to 0. If I am taking x common, so x plus 2 and minus 1 common, x plus 2 equals to 0. So I am taking x plus 2 into x minus 1 equals to 0. Okay. Now if I am taking x plus 2 equals to 0 or x minus 1 equals to 0. So x will be equals to minus 2 and x equals to 1. Okay. So there are two possibility values of your x, which is of your minus 2 and plus 1. Now they are asking us to write that solution set in the roster form. It means what we will write? We will take a capital letter which is representing our set, which is equals to the set of minus 2 comma 1. Okay. So this is how we are going to write the solution set for the given equations. Now let's see the next one. Write the set A equals to interval of 1, 4, 9, 16, 25 and so on in set builder form. So if you observe here clearly, in the given set we are having the elements individually. So now they are asking us to represent the same set in the form of a roster form. So how can we write? So let's take the given one, which is nothing but given set A equals to set of 1, 4, 9, 16, 25 and so on. Okay. If we take the given numbers, 1 is nothing but your 1 square and 4 is nothing but your 2 square and 9 is nothing but your 3 square. And if you continue like that, 16 will be of 4 square and 25 will be of your 5 square. Okay. Now we are going to write this set builder form for the given one. So now it becomes your A is the set of x where x is a natural number. So clearly we have to mention here whether x is what is the number family of the variable we are considering. Like if x is a natural number, we will give the natural number, and if x is an integer, we have to mention here it is an integer. Why? Because here I am taking natural numbers. Why? Because natural number starts with 1. So we are going to take it from 1, 4, 9 and 25 like that. Okay. But there is a possibility that we can take minus 2 whole square. Minus 2 whole square is also 4 and minus 3 whole square, that will be also 9. So our x values will be possible values are of plus 1 or minus 1 or plus or minus 2 plus or minus 3 like that. So which becomes our integers. Okay. But I can't include the integers. Why? Because I am not having 0. Okay. So we are not going to consider them as the integers. Why? Because we will get a doubt that minus 2 whole square will be 4 and minus 3 whole square will be 9. But coming to the integers, we are having 0. But in the given set, we are not having 0. So here clearly the x is a natural number. So we are going to take x is a natural number and square of a natural number. Okay. So here we are saying what is the type of the, what is the number family of the given, considering variable, and we are going to say what is the property between them. So clearly we are going to take it as the natural numbers, as 0 is not there in the given set. So we are not considering it as the integers. Okay. So the set builder form for the given question will become A is the set of x where x is a natural number and it is the square of a natural number. Okay. Now let's solve the next one. Coming to the next one, write the set of x where x is a positive integer and x square is less than 40. So here clearly they mentioned that x is a positive integer we have to take, and when we are taking the x square, that x square value should be less than 40. So let's consider a name x, let's consider the name of the set as A and take the common property given, which is of capital X. X is a positive integer and x square is less than 40. Okay. Now let's start with x is a positive integer as they told. So we will start with taking x equals to 1. Okay. So now if you take x equals to 1, x square will be of your 1. And if you take x equals to 2, if you take x equals to 2, it means x square will be equals to 4. And x equals to 3, it means x square will be equals to 9. And x equals to 4, so you will get x square equals to 16. Like this, how many values we have to take? We have to take till we are getting x square should be less than 40. So 4 square will be 16 and 5 square will be 25 and 6 square will be 36. And 7 square will give you 49. But we are not considering the 49. Why? Because our x square should be less than 40. So the collection will become A equals to set of 1, 4, 9, 16, 25 and 36. Okay. So they gave the question in the set builder form and we are going to find the roster form. So A will be equals to the set of 1, 4, 9, 16, 25 and 36. We are not going to consider 49 as it is mentioned that x square should be less than 40. Now moving to the next, we will discuss about analysis of the two sets. So like coming to here, if we are considering a set, like consider any set which is of B equals to set of the elements, if you are considering even 2, 4, 6, 8 and 10. Okay. Now what is the cardinal number or cardinality or order of the number, order of the set? These three are the same terms, cardinal number or cardinality or order of the set, which is nothing but the number of elements in the set. If you consider here, B is of 2, 4, 6, 8 and 10. So now the cardinality will be represented by n of B, which is equals to how many elements we are having? 5. Okay. So n of A or n of B means nothing but cardinal number, which will give you the number of elements in the set. Now we will discuss about the equal sets and equivalent set. Equal sets means if they have exactly the same elements. If the two sets A and B are having the same elements, then we are going to call them as the equal sets. And coming to the equivalent set, if you are having the same cardinality, like same cardinal number, then we are going to say them as the equivalent sets. Okay. And coming to the another important thing, we can consider the equal sets as the equivalent set. Why? Because equal sets means what? We are having the same elements. For suppose if A is having the 5 elements, then B is also having the 5 elements. So it means what? We are having the same cardinal number for A and B. So we can say that equal sets are equivalent sets, but equivalent sets are not equal sets. Why? Because just consider n of A equals to 5 and n of B equals to 5. But the set A should be of 2, 4, 6, 8 and 10. And the set B will be of consider 3, 6, 9, 12 and 15. Okay. If you observe here, we are having the cardinal number same. It means the number of elements in both A and B are same, but the elements are different. So that's the reason all equal sets are equivalent sets, but equivalent sets are not equal sets. Okay. Now moving to the next, we will discuss about the types of sets. First one is empty set. If we are not having any elements in the set, like consider B is of no elements in the set, then we are going to consider it as the empty set, and it can also be called as the null set, and it will be represented by 5. Okay. Why? Because 5 plays the major role in order to find the number of subsets that we are going to discuss in the today's class. So now moving to the next is the finite and infinite set. Finite set, the name itself will tell you how many elements are there. Like if we are having finite number of elements, then it becomes the finite set, and if we are having the infinite number of elements, then it will be of infinite set. Moving to the next is the types of set. Same in the types of set, we are having the singleton set. Singleton set in the sense, if A is a set of 3. Here if you observe, the number of elements in the set A is 3, which is nothing but only one element we are having. So this becomes your singleton set. Okay, and coming to the next subset. So subset in the sense, if I am having A is the set of 2, 4, 6, 8 and 10. Okay, and if I am considering B is the set of natural numbers from 1 to 10. So it is of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, if you observe here clearly, I am going to say that A is the subset of B. It means whatever the elements you are having in A, we are having all the elements in the set B. So we can write it as A is the subset of B. Okay, this is how we are going to represent the subset. So like it can be read as the A is the subset of B. Okay, so the condition is, if we are having a small a, it means element of the capital A. So small a belongs to capital A, then small a also belongs to capital B. It means the every set of the capital A should be in the capital B set. Now moving to the next, we will discuss about properties of subset. So properties of subset means, first of all, if we are having the same subset for two different sets, it means A is the subset of B and B is the subset of A. Then we can say that A equals to B. Now moving to the next, empty set is the subset of all the sets. So I am having 5. It means I am not having any element. So I can take it as the subset of every set. Now moving to the next, if A and B are the two sets and A is the subset of B and A is not equals to B, then we are going to call it as the proper subset. So the condition for proper subset is A should be A should be subset of B, but A should be not equals to B. If this condition is satisfied, then we are going to say that it is the proper subset of the, it is the proper subset. Okay, and B will be considered as the superset. If I am saying that A is the subset, then B will become your superset. Okay, so if we are considering A is the subset, then B will become your superset. Okay, now coming to the next one, every set is an improper subset of itself. So whatever the set we are having, so that set can act as a improper subset to itself only. Now moving to the next, so how can we find the total number of subsets in a set? Just consider that if you are having n of A, number of elements in the A as m. Okay, so it means in set A we are having the m number of elements, then number of subsets will be given by 2 to the power m. Okay, so number of subsets will be given by 2 to the power m. And from these subsets, how can we find the number of proper means? Number of proper will be given by number of proper subsets will be given by 2 to the power n minus 1. So now for any set we can find the number of subsets and number of proper subsets, where number of subsets is given by 2 to the power m and proper will be given by 2 to the power m minus 1. Okay, so here it is m. Moving to the next, if we are having A is the subset of B and B is the subset of C, then automatically A also will become the subset of C. Okay, now let's solve a problem. Coming to the next, we will discuss about the power set. Power set is nothing but it is the collection of whatever the subsets we are having. So non-zero, like non-empty set A. If a set is a non-empty set, whatever the collection of subsets we are having, that will be called as the power set. So simply we can say that collection of subsets of A. Okay, collection of subsets of A. Okay, simply the power set of A is nothing but collection of subset of A, and it is denoted by P of A. So how can we find the number of power sets? Means the same formula, P of A will be given by 2 to the power n. Now if we are having P of A equals to P of B, then we will get A equals to B, and if P of A equals to S, where S is the subset of A, okay, then how many, then what is the minimum number of sets in the power set is nothing but 2. Okay, so the minimum number of elements in the power set will be of your 2. So now moving to the next. So we are having one of the subset as the phi, which is nothing but the null set for every set. So now P of phi will be the set of phi. Now coming to the universal set. So a set is considered to be the universal set if it is the set of all the sets. Okay, so if it was a superset of any set, or it will be of the elements of the set given in the context. That means if we are having the natural numbers, so we can take a help of the our number family only. Natural numbers, and then after whole numbers and integers and rational. Okay, and then after we will be having the irrational, and then after we will be having the real and complex. So these number system will become your universal set, and whatever the rational, irrational, real, complex and integers, whole numbers and natural numbers, these all will become your subsets. Okay, so whatever the number family, like whatever the universal set we are having, that becomes the superset of all the sets with respect to that common property. Now coming to here, if you take an example, Z is given by 279, then P of Z. That means the power set of the Z will be given by the set of all the subsets of that set. Now moving to the next, if A equals to 1, 2, 3 and B equals to A, B, C, then we can write the universal set as combination of these two sets. So which is nothing but our 1, 2, 3, A, B and C. Yes, moving to the next, we will solve a question on the subsets. Mark the correct statement by filling in the symbols subset or not a subset in the blank spaces. So if we take an example here, 2, 3, 4 and 1, 2, 3, 4, 5. So when we say that it is a subset, if we are having all the elements of the, just consider these are all set A and these are all set B. Okay, if we are having all the elements of set A in the set B, then it will be considered as the subset. So 2, 3, 4. So these three elements already we are having in the set B. So we can say that the set of 2, 3, 4 is the subset of 1, 2, 3, 4, 5. Okay. Now coming to the second one, if you take an example of second one, it is of A, B, C. But coming to the set B is of B, C, D. We are having only B and C. We are not having the A. So now the set A will be not a subset of the BCD. Okay. Now moving to the next, X, where X is a student of class 11th of your school. Okay. Just consider that we are having the class 11 students in our school, and those will be formed as the subset for the collection of all the students in our school. Why? Because students in a particular school means we will be having all the grades. So from all those grades, grade 11 is one of them. So now the students of the grade 11 will become the subset of the students of our school. Okay. Now moving to the next, X is a circle in the plane and X is a circle in the same plane with radius 1. So here what we can say is, so we are having a plane, and in this plane we are having a different circles. Okay, just consider an example, we are having a different circles. And in those different circles, there will be a chance that we are having a circle with 1 unit radius. Understood? Now, the collection of all those 1 unit radius will be a set B. Okay. Now, the circle in the plane I am considering as the set A. So, we are having all the circles with 1 radius in the set of circles in the plane. But we are not having a circle in the plane, whatever the collection we are having as a set of circles in the plane, so that will be not the subset. So here it is not the subset. Now moving to the next, a triangle in a plane and B is the rectangle in the plane. So in the rectangles we are not having the triangles. Why? Because both are entirely different. So it is not a subset. Okay. Now moving to the next, X is an equilateral triangle in a plane and X is a triangle in the same plane. So if we take some of the triangles in the plane, then we will be having a chance that some of them will be the equilateral triangles. So these will be a subset. Okay. So now I think you can easily find out the last one. So just give the answer of the last one in the comment section. Now moving to the next, what universal sets would you propose for each of the following? The set of right angles and the set of isosceles triangles. So what you will think the best? So we can take entirely the set of triangles. Why? Because if we are taking the set of triangles, there will be a chance that we are getting the set of right triangles and set of isosceles and obtuse and everything, like acute and all. So the set of triangles will act as the universal set in order to consider the subsets as the set of right triangles and the set of isosceles triangles. Okay. Now you can answer the second question. You can give the answer for the second question in the comment box. Okay. Now moving to the next is the Venn diagrams. So what is the use of Venn diagrams means? We can represent the sets with the help of Venn diagrams. As you see here, so clearly we are we are using the circles and the rectangles. Mostly in Venn diagrams, we are going to use the particular shape for each of the set. It means for universal set, we will use the rectangles and the different letters and different shapes will be used for another type of the sets. So clearly we know that this is the universal set. It means whatever the elements we are having in the universal set will be from set of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. These are the elements of the universal set. Now when you get into the closure, we are having a set A with the elements of 2, 4, 6, 8 and 10. So which are multiple of 2. So 2, 4, 6, 8 and 10. Okay. Now once again, if you go closer, it was of your 4 and 6. So B is the set of 4 and 6. Now what can we do with the help of Venn diagrams means we can find the relation between the sets. How means, if you observe here clearly, we can say that B is the subset of A. Why? Because the elements of B we are having in the A. So we can write it as B is the subset of A. Okay. And whatever the elements we are having for the A, the same elements we are having in the universal set U also. So now we can say that A is the subset of U. Okay. So simply we can say that B is the subset of A and A is the subset of U. It means the elements of B will be also in U. Okay. So from there you will get B is the subset of U. So these type of relations that we can find with the help of Venn diagrams. Okay. And Venn diagrams are mostly useful to find the cardinal number of the sets. Like in our next class we will discuss about operations on sets. At that time mostly we will find the cardinal numbers. Okay. Now moving to the next, if you are having any doubts, kindly fill this form, and if you need any practice sheets and if you need any further guidance, you can log into our Telegram channel, and there you can find the practice worksheets on whatever the topics that we are discussing in the class. Thank you everyone. That's all for today's class.